We are very excited to welcome our keynote speaker, Professor Aline Villavicencio. Aline is the director of the Institute of Data Science and Artificial Intelligence at the University of Exeter, and also affiliated to the Department of Computer Science at the University of Sheffield. She has a fellowship at the Alan Turing Institute and is visiting professor at the Federal University of Rio Grande do Norte in Brazil. Before this, she held academic positions in the Institute of Informatics at the Federal University of Rio Grande do Sul in Brazil, and in the School of Computer Science and Electronic Engineering at the University of Essex. Her research on natural language processing includes the design and evaluation of large language models, multilinguality, idiomatic and figurative language, and NLP. She has co-edited special issues and books dedicated to these topics. We are delighted that Aline will be sharing with us her career trajectory and research highlights. Thanks, Aline.
So thank you so much for inviting me here. I'm delighted and completely humbled about being here on celebration for International Women's Day. And I couldn't be more appreciative of the opportunity to talk about my research and the research of others, with a spotlight on the research of the amazing women who have been working on data science and AI for several applications. So thank you so much. So next slide. And as Patty said, I'm affiliated mostly at the University of Exeter in the Institute for Data Science and AI. Next one. We are in an amazing time working on artificial intelligence and data science, because the technology that we've been developing for years and years is finally in a stage where it can be deployed for the good causes of getting a fairer, healthier, and greener society. And we rely also on the cutting edge machine learning and artificial intelligence methods that we are developing. So thanks to this basis, we can now apply to many of the good and positive outcomes. So I'm going to concentrate today on some of these topics here and then highlight some of the projects in which this technology has been applied. So next one. And I'll concentrate particularly on natural language processing, which is my area of work. So a few years back, I would have to explain to you what natural language processing was, but I don't think I need to these days, because everybody knows a few of the technologies that are out there, like, for example, the assistants, the chatbots like ChatGPT, Gemini, and so on. And we all use some information retrieval tool or another, like, for example, Google, Bing, and your favorite search engine. We also use a lot of technology, for example, for information extraction. So to get information about your favorite products, if you're thinking about buying a camera, you go and check for the reviews. And this is done, so the scores for the reviews are done using information extraction and sentiment analysis. So you know if you're buying a good product, an average, or if you should stay away from there. And this technology is also helping us, for example, doing things on the background, like telling you, for example, that this message contains some appointment and adding it to your calendar. And we've probably all used some machine translation tool or another to translate, for example, from English or from another language to English. And there are some amazing writing assistants out there. So if we want to polish a little bit the language that we are using, there are tools like Grammarly and so on. Not making any commercial announcements, just naming a few names there. And we also have assistants, personal assistants and chatbots. So for example, Siri, Alexa, Amazon Echo. And these are all working reasonably well. But the field has still a lot of challenges ahead of us. So for example, as soon as we start looking at non-standard English and social media language, for example, that we use, if we want to be really emphatic about something and we just repeat, I don't know, exclamation points, and I'm a big one for exclamation points, and putting emoticons and and this is not something that that we can predict. The technology is going to be able to cope as accurately as we would like to. And we are always inventing new words. So we have neologisms that are coming up all the time with, for example, advances in scientific advances. We need to create new terms for certain conditions, for new techniques, and so on. And of course, for language in general. So we have bromance, and we have this brunch, and we have all these different merges of words just to express concepts that we love. And of course, there is a lot of world knowledge that we use in our daily communications that the systems might not be aware of. So if I tell you, for example, that Mary and Sue are sisters, you may assume that they are related of the same family. But if I tell you that Mary and Sue are mothers, you are probably going to think that they have their own children, right? But the sentences are very similar. So, and this is common knowledge that we need to inject in our models. And then you have trick named entities. So, for example, A Bug's Life is the name of a movie, a cartoon. But the system needs to know that. So for every new movie, or Let It Be, name of a famous Beatles song. So the models are really great at what they do at the moment, but there is still a long way ahead. And then my personal field of work, which is idiomatic expressions and more figurative and creative language. So when I say that somebody is a dark horse, I'm probably referring that to their potential, hidden potential that is going to come up, and not that they are literally a horse of a dark color, right? And we have a lot of these expressions in all languages and fields, and they are conventional, and they are used sometimes to make difficult situations more bearable, sometimes to communicate efficiently, something that is a knowledge of the community. Next one. So, and the other issue, thank you very much. So the other issue is that not all languages are as equally resourced. So for example, if we think about the size of the training data for some of the good models that we see out there, we are talking about 1 trillion, right? And Llama 3 and GPT-4, 5 trillion words. And 6.5 terabytes of different, so the number of words in a training data. I mean, I can't even imagine what this number looks like. And here I'll just show you a little bit some excerpts, some analysis done by the European Language Equality Project, looking at different languages in Europe. And my apologies because the font is really small, but in the second column, so in the first column you can see some applications, in the second you can see which languages have good support, and then in the third moderate, and then fragmentary, and then really weak support. And most of the languages, unfortunately, are in the second half of the table, and some of them only on the last column. And we are talking about European languages. If we go outside of Europe, the situation increases even further. So there is a lot of attention in the natural language processing community about how to make languages more equitable for the models and for the technology ahead. But we may revisit this problem of training models, not thinking about how we can increase the training data, but thinking about how we can improve our algorithms, the methods that we use there. And one good source of inspiration is how we learn languages. So children learn languages in a really short time based on noisy input, being exposed to different linguistic communities, and having a proficiency in a language by the age of 3, 4, 5. Right, so they are really, really smart learners. And if we think about comparing the typical exposure that they have to language, A child by the age of 5 will have seen 30 million words typically, and a human at age 20, 150 million words. So if you compare that against the size of the training data being given by a model, it's, I don't know, order of magnitude smaller. So how do we do that? And we can take inspiration from what we know about psycholinguistics, about cognitive science, about biology, about how we acquire languages, and try to incorporate and create more psycholinguistically motivated, compatible language models. So, and this is not only helpful for our technology and the models that we are creating, it's also going to be really helpful, for example, for us to understand and simulate language evolution in humans. So if we want to understand, for example, how a condition like Alzheimer's disease affects language, if we have a model that is compatible with what we know about human languages, we can use it to simulate what's happening. So is it a problem of concepts being lost? Is it a problem of the algorithm that reaches those concepts that is working differently in some of these clinical conditions? If we have those psycholinguistically motivated models, we can do this kind of experimentations and help us understand how to better treat conditions that affect language. And then we can go on for a variety of different experimentations, like, for example, we can try to understand better if the algorithms are specific to languages, if it's one generic algorithm that we use no matter which language that we have. So lots of questions that people in linguistics and psychology have had for millennia. And the input that we have for these models are things like, for example, the text that we use, but we can also use data produced by humans, like, for example, fMRI, brain scans, eye tracking. We can use data from psycholinguistic tasks to compare the predictions of our models with the empirical data that we get from humans. And we know from our own communication that language can reveal a lot about the speaker. It can reveal, for example, that my native language is not English, and you may have guessed that it's Brazilian Portuguese. It can reveal something about my age and my state of health and well-being. And we use different languages also according to the situation. So the kind of language that I'm employing right now may tell you that I'm in a more formal situation, in a talk, rather than speaking with friends, although I hope everybody is going to be my friend here in the future. Okay, so I hope I have convinced you that there is a really relevant point in us looking at how we can learn from human biology and cognitive development about how to create more adaptive, efficient, and less data-intensive models. Okay, and these kind of models can be really helpful, for example, for us to handle certain situations, like when we are talking with, when we are trying to create technology for non-English languages, or if we are looking at clinical or psycholinguistic settings, when we have very limited data. So sometimes you can't collect as much data as is needed for training one of these models. And for dealing with low-frequency phenomena in general, like, for example, my famous idiomatic expressions, or very specific terminology where you have less data than you would have in typical domains. So, first things first, when we are dealing with natural language processing and we want to train a model, we need data. And data is usually in the form of texts. So one of the first works that I wanted to call your attention to is some work that we did for creating a training corpus, a training data for Brazilian Portuguese. So we created it 10 years ago now, and we shared it publicly. And to our surprise, it turned out to be very popular for training some of the state-of-the-art large language models that we have for Brazilian Portuguese. So it was funded by the Brazilian government at the time, and I think it continues to be one of the biggest. But if you compare, it's 2.6 billion, not the trillion that we were talking about before. We are still talking about a reasonably well-resourced language, not at the level of English, but still reasonably resourced. But if we look at some of the other languages, and my apologies because here we just have the abbreviations. So these are some of the languages of the Americas. And we have languages like Aymara, Quechua, and so on. And here you can see the training data and the sizes that we are talking about for this training data. So a few 100,000 if we are lucky, but some of them 3,000 different words. And a lot of the data that we have comes from the Bible and translations of the Bible. So that in itself has a lot of ethical implications that we need to be mindful of, right? And that gives you an idea about what level of difficulty we are dealing with here and how creative we need to be if we want to have technology for these languages. And this has been widely recognized, not only the importance of having a diversity of languages. So from 2022 to 2032, we have the decade of the indigenous languages. And there is a lot of interest in the natural language processing community on creating different technologies for vitalizing, not only for documentation, because some of these languages are really on the brink of extinction, so we would like to document them, but also we want to create technology for the communities that are there. So there are several initiatives in the area. For example, the indigenous languages of America, the indigenous languages of the Eurasian continent, Africa and NLP. So it's an important issue and it's recognized. And last year we had the first instance, the first edition of an event for the indigenous languages of Portuguese-speaking countries. And just to give you an idea, just in Brazil alone, we have over 200 indigenous languages, and more in the South America in general. So we are not talking about one or two, but we are talking about a lot of very precious cultural repositories. And here is one of my students, and he participated in a machine translation challenge for the indigenous languages of the Americas. And they both got first place, so they were really pleased about it. Another challenge in dealing with low resource languages. So we had 4 hours of recorded speech, and another of my students was doing some work on oral translation, because for some of these languages you don't have the transcription, all you have is the speech. So they were doing translation directly from Mboshi to French. And it was super challenging. So from everything from trying to decide where the boundaries of the words were to translating to the equivalents in French. And more recently, another of my students participated on the Baby Language Model Challenge. So how to train a baby language model, thinking about 30 million instead of 11 trillion. So in this challenge, it's a shared task, is open to the community. You submit your proposal, and her proposal was to actually make better use of the data. So using a technique called curriculum learning, where you order based on, for example, the frequency of the words. So you give the more frequent sentences with the more frequent words first, and then let the model learn from there, and then you give the more complicated ones. But there are, even in English, the systems, the models that we use out there, they aren't perfect because they are so big that they use not words in their dictionary, they use parts of words. Sometimes one character, sometimes two, sometimes three, sometimes full words, but not always. And we call this splitting up into pieces tokenization. And these tokenizers, they are not perfect. So you can see, for example, one unicycle there in the 1 to the 4th line, unicycle. You can see how the tokenizers split not in the obvious ways, like, for example, uni and cycle, because it would then at least ensure that you could link the unicycle, the cycle in unicycle to just bicycle and so on. And another of my students is looking at how to improve the way that this word splitting is done. And the other way in which you can try to make better use of the data is if you train your model on a highly resourced language, and then you use cross-lingual techniques to try to port some of the knowledge into the less resourced languages that you have. So a lot of the models that you see out there, they are multilingual. So they are supposed to work with English, with Chinese, but also with languages like Quechua. But the training data for these languages is going to be very different. So how do you make better use? And this is a really important topic. Okay. And now let's see if we can play this. No, I'm sorry, I think I just not going to be able to.
Why?
I could be chasing an untamed ornithoid without cause.
Any guesses? Wild goose chase. Thank you so much. So again, as non-native speakers, you may have made the same mistake as Lieutenant Commander Data, where you use synonyms for the words that are very conventional and very fixed, and you cause great confusion. And this is one of the issues that we are using to evaluate the quality of large language models these days. So we proposed some challenges to see if they could identify when an idiomatic expression was used idiomatically in a sentence. And spoiler alert, they are not so good at that. So we evaluated a variety of models, and this is one of the papers that we had last year. Again, my students, and they, to their great work was recognized by a Best Paper Award, where they evaluated a lot of the current state-of-the-art models, and they found that idiomatic expressions were still a challenge, which is great for us because it means that we can still do a lot of research. And just to give you an idea, this is not only in terms of text, but it's also for diffusion models or for vision models. So for example, here we have an image of a person who is feeling as right as rain, right? And any guesses? Cold feet, good. And the reason why we are here today is that we don't want to get into a situation where we have glass ceiling. Yeah. So we again put up a challenge to the community for them to evaluate and to send proposals of how the models would deal with not only text, but also images, so with vision. So we have one challenge, which is to define what is the best image that represents, for example, a bad apple in the idiomatic sense of a naughty person, or in the literal sense of a rotten fruit. And we have a second task that we call next image prediction, where we give a sequence of 2 images compatible with one of the senses of the idiomatic expression, and then we ask the models to rank which is the best image for the continuation. Okay, and if anybody knows anybody who is thinking about doing a PhD and would like to, I'm using this opportunity to say that I have an opening for a PhD studentship. All right, but in terms of applications of this technology, how can we make use of that? So one of the potential applications is, for example, is looking at language data produced in clinical conditions. And there are lots of different data sets, again, much smaller, because they are talking about clinical conditions, but there are out there. So for example, the Talk Bank has data about dementia, about aphasia, and other conditions there that you can use. And then what we can do, for example, is use some of the psycholinguistic tasks and the language produced by different participants and try to see if we can detect the triggers that psychologists, for example, or therapists or clinicians would be looking for. So for example, one of the tasks is the verbal fluency task, where people are asked to produce as many words as they can remember about a given category in 1 minute. So in this case, it would be animals. And what the therapists would be looking at is the kind of pauses, if there is too much fragmentation and so on. And we can use these models to help them identify those. So here is a similar kind of task where people need to retell a story. And it's some recent work that we are just finishing a publication about that. Fingers crossed, I hope to be able to tell you the story shortly. But this is some work, again, with colleagues in Brazil, looking at Alzheimer's. And in a recently just started project with some collaborators in Brazil, we are looking at how we can use chat companion to help handle cases of depression or possible depression. Because sometimes people are in very remote areas and don't have easy access to clinicians and so on. So if you can at least help them understand when it's a case of urgency. And this just started, this research just started. So another another important place where we can apply language technology is, for example, in retrieving from scientific publications specific information that can help us give evidence about a certain condition. So we are using AutoML, which is a machine learning technique, natural language processing and explainable AI to help doctors look at knowledge discovery, latent knowledge discovery from publications. And this is also a collaboration with some Brazilian colleagues in the Federal University of São Paulo. And very different from these two, another application that we have is on helping deal with postnatal depression. Again, in conditions where people don't have easy access to doctors, we are hoping to use language and sensors to track when people are more likely to require assistance in these cases. And now going beyond the research that I've been doing, other colleagues, for example, like Xu Jiongye, working on image processing and computer vision. She's looking at how you can use this kind of techniques, for example, to help you in medical decision making. So she works with conditions like lung cancer, brain, colon, heart, just trying to find where the relevant areas of interest are for a clinician. And when you are dealing with clinical applications, you really have to be mindful about, for example, considerations of privacy and sensitivity of the data, because it's the person who owns the data. And even though you want to be able to train your models with as much data for accuracy as possible, you need to be mindful that the data that you are using belongs to somebody, and you have to have their full agreement to use this data. So my colleague Anne Kayem is looking, for example, at cybersecurity and privacy preservation, how you can be include the patients as co-producers of the technology and making sure that the privacy considerations are followed. Another colleague, Magdalena Strauss, is a mathematician, and she's looking at how you can use data science techniques, for example, for personalized medicine and for drug resistance. And a little bit about the environment. So some of the machine learning techniques that we've been discussing can also be applied for other sources of image, not only clinical image, but for example, satellite image processing, images from radars and so on. So Milton Miltiado is looking at forest monitoring. How cool is that? So she's looking at satellite data and a large-scale Earth observation and LiDAR data sets in collaboration, for example, with the Met Office and the University of Bristol for monitoring the health of forests. Another cool application is in climate, for example. How can you use information from different sensors and how you can bind it effectively? Rachel McInnes has a PhD in astronomy and astrophysics, and she is the co-director of the Joint Center for Excellence in Environmental Intelligence, which is joint between the University of Exeter and the Met Office. And going back again to clinical applications, because of the limited amounts of data that we have sometimes in clinical settings, my colleague Julia Ive from UCL, she's looking at how you can synthetically generate data that preserves the properties of the original data, so can be used for accurate model training, but at the same time make sure that you still have as much of the anonymization as possible. Then Yulan He from King's College in London, she's looking at, for example, drug-drug interactions, how you can use language and publications in repositories to help you understand the explainability of drug-drug interaction and a visualization for drug safety information. Yulan is a UKRI Turing AI Fellow. Maria Liakata, another Turing AI Fellow, she's from Queen Mary University. She also works on NLP, and she's looking at multimodal data sets for dementia monitoring. And she's at Queen Mary. Another colleague, Heidi Christensen, she works with speech recognition, and she's using the techniques for speech recognition, for example, for helping to diagnose dementia and Alzheimer's disease. So she developed a technology called CognoSpeak, and she's also working to incorporate data from minority ethics. Because as we know, this technology is only as good as the training data that you give it. And if you only give data of a certain profile, the technology is going to be really good at that profile, but as soon as you are out, then it won't work so well. Another colleague, and I should say, Heidi Christensen is the head of School of Computer Science at the University of Sheffield. Another colleague who works on NLP, Anna Korhonen, she's the director of the Center for Human-Inspired AI, and she's the co-director of the Institute for Technology and Humanity at the University of Cambridge. And she also she's a linguist by training. And with the techniques that she developed, she was looking, for example, at how you can do literature-based discovery for cancer biology. And how to use text mining, so when you extract information from texts, automatically to aid cancer risk assessment. And one of our role models, Karen Spark-Jones, she was a fellow of the British Academy, and she was a self-taught programmer. If I'm not mistaken, her background was in library sciences. And she is responsible for one of the concepts that is mostly used in information retrieval systems, which is the inverse document frequency. So she basically created a whole area of research. And of course, Jean Golding, who is still active here in Bristol as a mathematician and epidemiologist. And now going a bit further afield, so my colleague Elena Caselli from the Federal University of São Carlos, she also works with natural language processing. And she's doing really interesting research on depression, so one of the projects is with her. But what I also wanted to raise, to talk about from Elena's amazing work, is that she realized that there were a lot of women in the Brazilian community, but everyone was on their corner, so she created this Brazilian in NLP groups, and the group has more than 200 members, and the group wrote together a book on NLP in Brazilian Portuguese for Brazilian Portuguese community. So talk about democratizing science. And then to finish, Marcia Barbosa, a physicist, she works with research on water properties, and her research is really, really impactful, for example, for the environment. And she won several prizes like L'Oréal UNESCO Prize and Claudia Prize, and she's the director of the Brazilian Academy of Sciences, and now, just this year, she's the vice chancellor of the university there. And as women out there are several initiatives that are really, really wonderful. Like, for example, the British Computing Society Women Lovelace Colloquium. And the next colloquium is going to be in Glasgow this year on 16th of April. And it's open for undergraduate and master students working with computing in the UK, in some area of computing. And you have several initiatives, and I'm just going to go quickly over them. Apologies because my time is up, but the slides are there if you want to see them. So that's what I had to say for today. And as you see, we are women, and it's women's celebration, women plus, women and non-binary. And I'm thrilled to be here today. So if you have any questions, I'll be happy to answer them. Thank you.